It started out with graphene and then it went to functions. I'm doing FOIL to solve x. Next is the expressions. Now I have to see if x is equal to or greater than 3.
Hey guys, let's go over our introductory video for square root transformations. And this is for a0. And the equation we're going to be using, our function, is f of x equals the square root of x. Now, a square root is actually denoted with a power of 2, and a lot of times you're actually not going to see that 2 there. But let's go ahead and make a graph. So what we're going to do is we're basically going to put in values of x, and when we simplify it, we will get an output value that is a y. Okay? So let's put in 0 here. And the square root of 0, you're trying to think of two identical numbers that multiply to be 0. That is actually 0. So I can put that one right here. Okay. Now let's think strategically. I would not want to pick an x value of 2. You could, but it'll be a decimal. So if I pick a perfect square like 4, what is the square root of 4? Well, that would be the number 2. Because 2 times 2 is 4. Square root of 4 is 2. The pairs, so let me write that. These will come out in pairs, so that would be just a 2. And the previous answer, it was a 0. So when x is 4, our y value is 2. And then if you just do, if you pick the number 9, because 9 is a perfect square, so the square root of 9 would be 3 times 3, and those 3's can come out, your answer would be 3. So 9, 3 would be on our graph, okay? So this would be the parent graph of the square root function. And let's talk about some characteristics. Okay, so if we're trying to transform this, using f of x equals a square root b x minus c plus d is the number or letter. So here's the first one. Let's make sure we understand that the square root, or the radical sign, is this symbol right here. Okay, this will kind of give us the hint. And we're talking about, is it in the inside? So if it is on the inside, then we have this B letter. Try to make that thicker. There's the B. Okay, you'll notice that the B affects the X values. If it's also on the inside there, not in the underneath the radical sign in orange, okay, those all affect the X values. Now, if it is on the outside of the radical, for example this one, it is the A value if it's in the front there, and that affects the Y value. And then lastly, we have the, if it's to the right and outside of the radical sign, that is our D value, that affects also the Y value. So you need to think about, is it going to affect the X or the Y? So let's review. Number 1, we're using that formula there. A and B, we're just thinking, is it inside the radical or is it on the outside? We'll also identify the A, B, C's, and D's and how that translates to its characteristics. And then D, does it affect the X or Y? Write down that order pair. So what are the characteristics of that radical function? You can write down a couple of these. You don't have to write down all of these. We'll actually do that on the next slide. So if you guys think back to transformations in 1.32, we actually talked about this quite a bit. So let's just go through these. Your A value is going to be a vertical if your a value is less than 0, we're going to talk about how this is a compression. If it is greater than 0, then we call it you take the absolute value of a, and this will be our compression stretch or compression factor. And then also, if that number is less than 0, or a negative number, then it's going to reflect over the x-axis. Reflect over the x-axis. Okay? And then our b value, you'll notice that it's on the inside. This is going to be horizontal. Some horizontal movements. That just means the going left or right. And it has a stretch or compression. Think of your compression sleeves or stretch your arms out when you're tired. That'll be in a factor of absolute value of 1 over b. 1 over b with absolute value. And if it is less than b, if it is less than 0, so a negative number, then it reflects over the y-axis. Okay, so it should feel very similar to what we learned previously in just polynomial transformations, right? With power functions, x squared, x cubed, quartic functions. Okay, this c value, or sometimes textbooks will call this the h and the k, this is the horizontal translation. Okay, this is where students have some difficulties, okay? If c is greater than 0, it's going towards the right. If c is less than 0, it's actually going to the left, okay? And my silly phrase, here's the reason why. If c is less than 0, which means it's like a negative, so say negative c is negative 1. If you put it in here, the opposite of negative 1 would be x plus 1. So I have this silly phrase I learned from Professor Berger, that's his name, add to x, so if you see a plus sign in the example, add to x, go west. And west is actually going left. So that's kind of like a trick phrase that might help you, okay? And then the last one over here, this is going to be our vertical going up and down movement translation. And essentially, if your d value is greater than 0 or positive, you're going to go up. If it is less than 0, you're going to go down. And the silly phrase for this one is add to y, go high. Okay, so that is our introductory video for A0. We'll see you guys. Let's go ahead and do A1. We're going to sketch this transformation, and then we're going to write the equation. So it gives me the parent graph. And I definitely want to highlight some points in here we did in the intro video, 0, 0, 4, 2, and 9, 3. And this one over here for A1 is saying translate the graph up 2 units. So if I have to think of a letter A, B, C, or D, this is going to be a D. And going up is positive, so D is a positive 2. So if I had to write a function for this, you know, if you have the A, B, X minus C, and then the plus D, well, you only need D equals 2 here. And then everything else you don't need an A, B, or a C. So then all you have to do is just write f of x equals the square root of x plus 2 is your answer. So this would be your answer right here. And then to get your graph, all you're doing is you're actually just moving these up just 2 units. So count 2 units above what you just did from the parent graph. And then you can just make this sketch going this direction. And that's your answer for A1. All right, let's read the description for A2. Translate the graph down 5 units. Okay, so remember, I need to have the parent A square root B, and going down is going to be a D equals a negative 5. We talked about the characteristics. D going down is negative 5. So this value is just going to be negative 5. And I don't need the C, B, or A because that's not in ours. So my equation is just going to be f of x equals the square root of x minus 5. And this is going to be our answer. One in red. Can you give me red? This red right there. Okay, so let's go ahead and graph that. Remember, it has some key points that we need to get. 0, 0, 4, 2, and 9, 3. So these reference points for the square root function are super helpful. And then I can just go down 5 units. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then I can just get my graph in here. And that's what my graph looks like for A2. All right, A3, we need to translate this 4 units to the left. So you have to pick a letter. Is that A, B, C, or D? In our intro video, going left to right is the C value. So left is going to actually be C equals negative 4. Okay, so let's make sure we don't need A, B, and we don't need D. I'm going to do this one super careful. This is probably the hardest one for students. So C is equal to a negative 4. Okay, let's write that in. I'm going to use blue. So I don't need A, so I just have the square root of x. Now I'm going to put this minus sign there, and we have negative 4. And basically to clean that up, you're just going to have f of x equals the square root of what? What's opposite of negative 4? X plus 4 is your answer. Okay? And remember, that goes back to my silly phrase. I'm going to write it because it says going left, but in here it says a plus sign down here. Okay? So that is, the silly phrase is add to x. So do you see an add to x right here, down here? Go west or left. Okay? So that reinforces that silly phrase. Okay? Let's go ahead and highlight those key points there. So 0, 0, 4, 2, and 9, 3. Okay? And now from there, we're just going to go left on each of those 4 units. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then my graph is going to look like this. Okay? And so that is A3. Alright, A4. We have to translate the graph, right? 7 units. You can do visual first. So here again is some key reference points you need for the square root function is 0, 0, 4, 2, and 9, 3 from the introductory video. And now it's telling me to go right 7 units. Okay, this is not good because I didn't give you a good graph, but let's just count, okay? And then you can kind of see what would happen. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And just do your best to keep counting the same way. 1, 2, 3, 4, 5, 6, 7. And then here is my graph. Okay, that's doing it graphically. Okay, let's do it by the equation now. So I'm going to write down the parent function. F of x equals a times the square root of b parentheses x minus c plus d. And I need to think about, well, what letter is going to the right 7 units? That's going to be a c value, and it's positive, so it's just going to be c equals 7. I'm going to use my highlighter, c equals 7. Let's write that in there. Okay, let's cross off everything we don't need. I don't need the A, I don't need the B, I don't need the D, okay? And one thing I'm going to pay attention to is this minus sign. I'm going to put it right there, okay? Let's go ahead and write this. So I have f of x equals the square root of x minus 7. So I want to point out that this is kind of like opposite inside. Do you see that? That's minus, so you normally think left, but this is what? Going towards the right. And goes that silly phrase, add to x, go west or left. Now, pay attention. Does this have any adding? No, so you're doing the opposite of this. You're not going, if it's, you're not going left, you're going what? Right. So that's how that silly phrase works. Let's go ahead and sketch the graph and also write the equation, okay? I have, it says vertical stretch by a factor of 2, and you're going to have to think about which letter is that, A, B, C, or D. Well, the verticals is going to be referred to the letter A. So my A is equal to 2. Let's write the equation because I think it'll be easier. So again, if you write everything, f of x equals a times the square root of b parentheses x minus c. That one's a little bit too long. Then the d is on the outside. Well, we don't need the letters b, c, or d. So my a value, that is 2, we're just going to write it there. Let's go ahead and do that. So I have f of x equals 2 times the parentheses of just square root of x. And that's actually my answer. Okay, the parent graph, again, has these points all the time, okay? So 0, 0, 4, 2, 9, 3. Okay, that's the parent function. But if you think back to the transformations, the b value and the c value affect the x. I put there in blue, and I'll put here in green. The a value affects the y's, okay? How does that work? Well, if you think about the order pairs, let me just write those really small. I should probably use the pen function, so let's use, that's way too big. 0, 0, 4, 2, and 9, 3. X, Y, X, Y. Okay, so if you're taking an a value that is 2, so you just put the 2 here, so you're just essentially going to have x, comma, 2y. Okay, how does that work? Okay, the x value stays the same. Okay, but you take the y value and you're going to multiply it by 2. Okay, so let's try that for the next one. So if you just put in 0 for x, you're going to get a 0 for y. 0 times 2 is 0. So that is the child function I call. Okay, so the next problem says x is 4, so that's just going to go here, and that's going to be 4. Well, if you take the 2 and put it in here, 2 times 2 is what? 4. So that's the new coordinate. 4, 4 is my new one. Okay, and you'll realize it's just double or being stretched vertically, going kind of like string cheese or when you're eating pizza and you pull it up. Let's try the next one. So this one is x is 9. But then the y value is 3. So 3 times 2 is 6. So the order pair now is 9, 6. And let's go ahead and sketch our new function. And it's going to look like, I want it orange. Purple, orange. Let's do orange because I said orange. Here is my new graph. Okay. Can you see, hopefully visually, that the graph is being vertically stretched this direction like cheese? Okay, from the parent graph below. So that was question A5. A6 tells us to reflect the graph over the x-axis. And the question is, which letter does this refer to? Is it an A, B, or a C or D value? Okay, so you can just do process of elimination if you need to. This is a vertical translation. This is going left to right. No. Okay, this one refers to reflecting over, if this was a negative, which we have no number there for ours, that would be a B value, and that's also the horizontal stretch or compression. But this one here is ours. Guess I should have done it in green, but kind of like green for go. This one is ours because it tells you to reflect over the x-axis. So that means the A value, go back to purple, A value must be -1. Okay, so that is the big idea. So let's go ahead and just write the function now. Here's my parent. A times square root of B times x minus C plus D. And we don't need the B, C, or D. And the A is just going to go right there. So let's go ahead and write it out. So f of x equals a -1 times, we just need that x. All the other stuff, the minus, the parentheses, you don't need because we don't need B and C and D. So that's actually our answer. And you could just write the negative sign in front of the square root would be fine. Okay, so how do you graph this now? I'm going to just put the reference points back in. So this is a big idea. 0, 0, 4, 2, and 9, 3. That is always the case because that's how you actually graph it. Okay. Now it's telling us to actually go over the x-axis. So let me highlight the x-axis here. And you're gonna, it's like a game. You got to jump over the x-axis. Well, 0, 0 is the same. Instead of 4, 2, this is going to be 4, -2. Instead of 9, 3, this is going to be 9, -3. Okay. So here is my new graph. Just in case you wanted to do this problem, so the green is the answer of our graph. If you ever wanted to do that by coordinates, you would just essentially do, 0, 0, 4, 2, 9, 3. Then you would realize that the rule that you're creating is the A value affects the Y. So this would be kind of like AY. So this would be X times -1 times Y. So that basically means you would multiply all these number times -1. And that would give you the new, sorry, it's kind of messy, but 0, 4, and 9. This would be 0, -2. Your Y values become now negative. And that's why I reflected over. So that is A6. See you guys.